Now we're going to look at the final problem for tonight. This is example 6.3. It's entitled Either Or Manufacturing, but we also refer to it as the Dorian Auto model, not to be confused with the DeLorean Auto model. I guess we ran out of flux capacitors. Huh? But anyway, this problem is another problem that requires us to consider the use of binary variables. But the reason is because we have decisions to make. The reason we call it either or manufacturing is because we have assembly lines that can be used to produce either this model or that model, but not both. And in addition, we have capacity constraints that are determined by what we're producing. So if we produce one model, we may have X capacity. We produce the other model, we have Y capacity. And so we need to be able to modify our capacity depending on whether or not we're producing that particular model. Let me go ahead and read the problem statement. Dorian Auto is considering manufacturing 3 types of cars, compact, midsize, and large, and 2 types of vans, midsize and large. The resources required and the profit contributions yielded by each type of vehicle are shown below. At present, 6,500 tons of steel and 65,000 hours of labor are available. So here's our steel resource, here's our labor resource. If any vehicles of a given type are produced, production of that type of vehicle is economically feasible only if at least a minimal number of that type are produced. These minimum numbers are also listed. So if we produce a compact car, we have to produce 1,000, midsize 1,000, large 1,000, and the vans are capacities of 200 each. These minimum numbers are listed. Dorian wants to find a production schedule that maximizes its profit. Okay, so our decision variables are going to be what? It's going to have to be somehow or other keyed to our production plan, right? So what does our production plan look like? Well, the way I see it, it looks like units produced, right? Do you agree with that? Is that our production plan? Why not? It's as good as any, right? All right. But we also have to decide whether or not we're going to produce the car, right? So we actually have 2 sets of decision variables. We have the decision variable of how many to produce, but first we have to decide whether or not to produce. Now, this is where we're going to be looking at throwing the switches, okay? If we decide to produce the compact car, let's just make a 1 there, 1 being yes, 0 being no in this case, okay? If we decide to produce at least the minimum, then that means we're going to have to produce 1 times the minimum production, right? Does that make sense? And The other thing that we have to understand is whether or not that influences our capacity. So we're going to have a lower bound that units produced has to be greater than or equal to that amount, right? And then an upper bound. How are we going to determine the upper bound? It's going to be a resource constraint, isn't it? So that is going to be, let's think this through. We've got, I'll do it this way. We've got steel and we've got labor hours. If we use all of the steel to produce this vehicle, then I'll just do the calculation here off to the side. Compact car. All right, if we use all of the steel, that would be 6,500 divided by 1.5 per car, right? So that says we could build 4,333 cars if we used all of the steel to build that particular type of car. But we also have a labor constraint, right? The labor constraint is 65,000, and we use 30 hours of labor. So that says we can only produce 2,167 cars using that labor. So what is our logical capacity then if we choose to produce the compact car? It's the smaller of the two numbers, right? How would we model that in Excel? Well, how about this? How about if we modeled it in Excel by taking the minimum of resource available, I'm going to make that a fixed value, divided by steel, and labor hours divided by labor. All right, so there's my 2167. Thank you very much. You're too kind. All right, so is that my logical capacity? What if I choose not to produce that vehicle? What would happen to my capacity then? It should be zero, right? Yeah. So how do I get the logical capacity to be zero if I don't produce? Multiply by what? By the binary variable, right? So if I put at the beginning of this times minimum, all right, so now if I choose not to produce, lo and behold, my production, I'm bounded now by zeros, right? And my decision variable, my units produced decision variable, has no choice in this case but to be zero. You see what I'm doing here, folks? I'm using my binary variable to do two things. I'm using it basically to establish what my minimum production rate is based on what it's told me in the problem statement. And I've also used it to cap my production rate so that I don't go over my capacity constraints. All right? Now, you say to yourself, well, but wouldn't that ordinarily happen anyway here? Well, may not. It may not. What we're doing is we're trying to make sure that we don't allow an infeasibility to creep into the problem. All right, so I'm going to put ones across all of these right now because, again, what I'm doing is I'm trying to troubleshoot the problem statement or the problem before I do it. So I should get those values there. So those look correct. And what about the capacity constraints? Well, just eyeballing it, it looks like the capacity constraint is going to be about the same for the midsize car.